There we go. All right. Oh, there's nothing on the screen. Why is there nothing on the screen? Come on, technology. Can't believe 20 years ago I just used a piece of chalk. All right. So, hey, how do you... This section, chapter 3, is all about fair division. So remember what this class is about. How to use math, real world, help things happen. Chapter 1 was all about voting. Hope you guys got all that information real good. You get your 3x5 card ready also, right? You can use a 3x5 card, anything you want, front and back of that thing. If you don't have that ready, get that completely ready. Make sure that chart I gave you in the handout is on there, right? A lot of questions right from that. So anyway, chapter 1 was all about voting. What are ways to, with fairness, with truth, determine the will of the people, right? A bunch of people vote, and we realized it's kind of tricky in that there's actually no best method. There's no method that doesn't have a flaw. Every method of determining the will of the people can do some unfair things, huh? That was chapter 1. But still, there's some that are better than others, and we learned a lot. Math helps still. Chapter 2 was all about weighted voting, right? That's like the Electoral College, or, you know, anytime you have different people that have different amounts of votes, like a stock company or all kinds of governments, weighted voting, and how to determine Bonhoeffer power, how to find out how much power you really have. Math comes in and helps people know, hey, in this system, here's how much power you really have or really don't have. Now, chapter 3 and 4 are all about how to separate things. Or, you know, fair division is chapter 3, chapter 4 is apportionment, kind of the same thing. It's basically, how do you take something and break it up fairly among a bunch of people? The classic example, the example well, this is the classic example. The most common example in society today would be inheritance, right? You read it all the time, right? Parents die, 3 kids, they inherit the stuff, they squabble among each other, sadly, and sometimes, and argue, and it all goes to court. The lawyers get all the money anyway. But anyway, what are some systems to fairly divide up a bunch of stuff? Say you have an inheritance and the parents' house and their business is broken up. There's a house and the business, that's 2 things, but there's 3 kids. What do? I mean, do you just sell it all and break up the money? I guess you could do that. But sometimes different people value different things. Somebody really values the house because they were raised there and it's worth more than the monetary value to them. Anyway, on and on you go. We're going to learn in this chapter, the goal of this chapter is to fairly divide things. And that's a little more tricky than you might think because different people have different value systems. Like here we go with Jorge and Carmen and Jorge, right? Chocolate strawberry mousse cake, $60. They go buy this cake together. Suppose that Carmen values chocolate 3 times as much as strawberry. That's just how Carmen feels. So, for example, if you were to cut that cake right down the middle and say, all right, Carmen, you get the strawberry half, and Jorge, you get the chocolate half, would Carmen feel like she'd gotten a fair deal? Carmen likes chocolate 3 times as much. So if you only gave her the strawberry half, would she feel that she really got half of the value? No, she thinks the chocolate part's worth a lot more than the strawberry. She would not believe that she had been treated fairly. That wouldn't be a fair division in her eyes. So you see, that's a little tricky, huh? What to really do, what our goal is in this section, in this chapter, is to use math to help divide things fairly, meaning when it's all said and done, both Jorge and Carmen will say, yeah, according to my value system, which is different for each person, right? Jorge, he might like chocolate as well, or he might like the strawberry better. He might like them equal. Who knows? He hasn't told us yet. But each person will tell their value system, and then you break up the cake in a way where both, when all is said and done, feel they've been treated fairly. And here's the trick. It would be simple if they just got along, right? If everybody in society just got along. If those 3 kids inheriting their parents' stuff just got along, they could sit down and they could talk it out and they could say, what do you really value? I care about you. I want you to get something good, not just myself. And they worked it out. That's always the best. We didn't even need all the math. But the truth is, in reality, many situations where things are divided, there's hostility. There's just selfishness. And so people are not going to, by their own free will, give fair treatment to everybody or really care what the other person values. So the goal of the math then is to come in, even in those situations when the people are hostile, trying to not share fairly, and they all have different value systems, chocolate, strawberry, whatever, the parents' house, the the $1 million painting in their front room. I always loved it as a kid, or I've always hated it. You know, different value systems, hostile situation, and math still come in and do it and break it up in a way where when everybody is done, they will look and say, yeah, I got a fair share based on my value system. That's pretty tricky. That's the goal of this chapter. You can see why it's the most complex chapter. So let's start with the classic example is the divider, chooser, the cookie. Have you ever thought about that? I don't know if you guys don't look like you're nearly as old as me, any of you, even in my neighborhood. But I've got kids. Maybe you've got little siblings or nephews or nieces or something. Have you ever had two kids divide a cookie, or the last cookie, or the last whatever, some kind of treat? You ever seen the way they do it? Right? It's just like a battle, right? I mean, unless you're people you know are much more noble than my children. But if you got the last thing, and you send my youngest. We've had 5. My youngest 2, John and Abby. If I send, I'm putting their names on the wall. Why do I do that? Anyway, send John and Abby over, and I say, John and Abby, go share the cookie. That doesn't work. If I go share the cookie, John will try to break it up, and Abby will go, no, that piece is bigger. My all this arguing, all this trouble, right? So, have you heard this? It's not just my little thing, right? The classic answer is one person cuts, the other person picks. I've literally done it. It works like a charm. So there's all this fighting, with the last cookie, and I go, Johnny cuts, Abby picks. Get the idea? Johnny is going to take that knife, and he's going to cut, right? He's going to cut that cookie. Abby picks. So Abby's watching John. And as soon as John starts to go a little bit off center, Abby's eyes get big. And she's like, oh yeah, I'm picking that one, baby. You go ahead, John. And John, realizing that, and he's back over here. John is suddenly like a surgeon. I mean, he can cut that thing beautifully 50-50 because it's now in his best interest, you see. So that's just one example of how math comes in and says, even though you're hostile, I can come up with a system where you will divide it fairly. That's one of many examples of what we'll do. And it works just like that. John is suddenly like a surgeon. I've seen it. Because Abby gets first pick. So, that's the classic example of, it's called divider chooser. One person divides, the other chooses. We'll have various different takes on that. All right, that's basically what we have here. So, Carmen and Jorge, they're going to divide up the chocolate strawberry mousse cake, $60. Remember, Carmen, what's really important, are we on the, oh yeah, I'm on the thing already. What's really important is their value system. You got to put on their glasses constantly and look at the world like they look at the world. So in this section, how does Carmen look at the world? Carmen values chocolate 3 times as much as strawberry. So remember that as you go through. That's how she feels. So find the dollar value to Carmen of the chocolate half of the cake. So let's do that first off. So we got this cake like this. We got it's chocolate down here and it's strawberry up here. So this will be Carmen. Jorge's going to look differently at the cake, but let's just do Carmen right now. So Carmen, how does Carmen feel? Well, it says here that she values chocolate 3 times. The whole cake cost him $60. So she looks at the whole cake, it's worth $60. That's what they paid for it. But it's not 30-30 to her, is it? Carmen doesn't look at it and go, yeah, the chocolate half is worth $30 and the strawberries half's worth $30 because we paid $60. No, that's not how Carmen feels. She doesn't think they're equal value, does she? Well, what does she think then? It's 60 total. Well, what is it? It's not 30-30. What is it? Anybody know? Is it 20-40? 20-40? Would that be right? How about 20-40? Is 20-40 right? That's $60 total. But that would be valuing chocolate how many times as much as strawberry? Is twice as much? Isn't that chocolate worth twice as much? But that's not what they said. She likes it 3 times as much. Chocolate is supposed to be 3 times as big as strawberry and the total 60, huh? That's what they're saying. Carmen likes chocolate 3 times as much. And to her, the worth, the monetary worth of the chocolate is 3 times the strawberry, not double. So 20-40 won't work. Well, did somebody else have another answer?
45-15.
25,
45, 15.
oh, 45 for chocolate, 15 for strawberry? That looks good. That's it, huh? Because that's 3 times, and that totals 60, huh? That's how Carmen, now I'll help you find that out. If you don't have to just guess, I'll give you a method. In fact, let me just show you right now. That is the right answer. Here's how you can get, guessing is fine with me. You know, I have nothing at all against guessing. But in case you'd rather have a method, you know what you can do? You could use algebra. You could call this one x, and this one 3x. And then x plus 3x equals 60, and then just solve for x and you'll find that number. This is another, but you want to just guess, feel free to do that too. So, do everybody see what I'm doing? So here would be the surefire way that would always give you an answer. Just call it x and 3x. Why 3x? Because 3 times, huh? She likes chocolate 3 times as much as strawberry. That's how Carmen feels. And together they got to add up to be 60 total, right? $60 cake value. So what is x and 3x? 4x. Remember algebra days? Remember your glorious algebra days? I don't know if they were glorious, but remember how there's a 1 in front of that one? 4x equals 6. Remember to add like terms, all that? Then how do you solve for x here? Remember from algebra? Just divide, right? Divide both sides by 4. And x will be, what's that, 15. So there's that. So x is 15, and this is 3 times 15, as we already knew, 45. See how that'll lead you to the 2 answers? Like that. You do all this work. X comes out 15. Then you just plug in 15 for x. So strawberry is 15, chocolate is 3 times 15, 45, as we already knew by good guessing. Does that make sense there? How to do that? So when they tell you somebody likes something 3 times as much as the other, you just call them x and 3x, add them up to be 60, solve for x, plug it in. All right. So there's how Carmen, so that's why the $45, oh yeah, it's right, it's right over there the whole time, huh? So $45. That's what she thinks of the chocolate half. There's what she thinks of the strawberry half. Okay, good so far? Find the dollar value to Carmen of the slice of strawberry cake shown to the right. How much is that 60-degree angle strawberry chunk worth to Carmen? How do you take like an angled cake? Nobody talks that way, huh? I'm going to cut a 60-degree piece. But what can we do with it? You don't have to know a bunch of geometry. You really don't. Let me just draw it again up here for a minute. Here's the strawberry half, right? Just leave it like that. How many, do you guys know how many degrees in like all the way around? 360, right? So, oops. So that means right here in half the circle there's 180. Right, 180, 180, 360. Right, so the strawberry half, the whole strawberry half is 180 degrees, isn't it? Right? So this 60-degree thing over here must be 1/3. That's my point. Right? Must be 60, 60, 60 to make 180, huh? My point is this is 1/3 of the strawberry. That's all you need to know. 60 degrees is 1/3 of 180. The whole strawberry is 180. So this is 1/3 of the strawberry. Does everybody see how I'm coming up with that? So you just say, okay, we can do this. It's just 60 out of 180, 1/3, or just 1/3. That's a fancy 1/3. But I'm just giving you a method with whatever angle they give you over the total for that piece. So it's 60 strawberry over 180 total strawberry, or just 1/3 if you want, times the value of the whole strawberry, $15. So really it's 1/3 of $15. That's why they got the $5 answer. Does that make sense? For Carmen, the strawberry, the whole strawberry is $15, so break it into 3 parts. The strawberry is worth $5, $5, $5 for each of those 60-degree angle cuts, right? 5, 5, 5? Good. Am I going too quick? Does that make sense? So you just take the angle. It's 60 out of 180 times 15. $5. Now, let's find the dollar value to Carmen of the slice of chocolate to the right. 45-degree chocolate piece. 45-degree chocolate piece. So how do I... So, to see how to figure that out? Again, the chocolate half is also 180 degrees, right? It's a half a circle. Half a 360, 180. So then you just take 45 out of 180, which is a fourth, by the way. You might know that's just a fourth. 45 is half a 90, which is half a 180. So it's half a half, it's a fourth. So if you just look at that and go, hey, that's a fourth, great. You don't need to mess with this. This is a fancy fourth, right? 45 out of 180 times, what's the whole chocolate thing worth? Because it's that portion of, and of always means times, huh? It's that portion of the whole chocolate piece. What's the whole chocolate worth? 45. So it's 1/4 of 45, which is that 1125 answer that they got. Does that make sense? So right now we're just kind of warming up. We don't have any official methods yet. They're just warming us up on learning to see how people value things. So that's the first thing, right? Our goal is to give everybody a fair share in their value system. That's a little tricky. Everybody has a different value system. Everybody feels differently about things. So it's a challenging thing we're going to do. So first off, just getting used to how Carmen, taking a person's stated words and turning it into numbers. There's how Carmen values things. Chocolate is 3 times the value of a strawberry. Therefore, how would she feel about a 60-degree angle strawberry piece? She would say that thing's worth $5. How would she feel about a 45-degree chocolate piece? She'd say that thing's worth $11.25. She likes that. That piece of chocolate's smaller than that piece of strawberry. 45 degrees is smaller than 60. But she likes chocolate so much better that it actually comes out to be worth a lot more to her, money-wise. So that's where we begin, is learning to put on Carmen's glasses and value things as she values things. No questions? That good? Yeah.
The 45 over 180, is that the angle or the dollar amount?
That's the angle, yeah. So the 45 is the chocolate angle out of 180, because that's half the cake. That's the whole chocolate's half the cake. Times the $45 that the whole chocolate half is worth. So it's that portion of means times, of the whole chocolate. Or of the chocolate half. So that portion of the chocolate half is what we're doing. Is that good? Should we go on to part number 2? If you're okay. All right. Okay, so now what they're going to do is they're going to give some kind of cake. They're not even showing the cake. Alex, Betty, and Cindy, A, B, and C, are sharing a cake. Suppose that the cake's divided into 3 slices, X, Y, Z. Table on the right shows the values of X and Y to each of the players. Values of Z are missing. The percentage represents the values of the slice as a percentage of the value of the entire cake. Blah, 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 blah. All right. So, in other words, let me try to make a little more sense out of this for you. Let me put it over here. So basically, there's some cake they're not showing us. Let me just make up a cake up here. There's some kind of cake they're not showing us. And it might have strawberry in some parts, and chocolate and vanilla, and frosting or not frosting, or filling or not filling, or whatever. And there's some kind of piece X, and there's some kind of piece Y, and there's some kind of piece Z. The whole cake has been cut into 3 parts, X, Y, and Z. I don't know. They're not showing it to us, and they have different characteristics, those 3 pieces. Well, and then Alex, Betty, and Cindy are each sharing how they feel about the cake. You know, once the cake has been cut into those 3 pieces, X, Y, and Z, Alex, Betty, and Cindy are sharing their feelings on it. So let me do that real quick. So I'm going to go Alex. I want to make that chart over here a little bigger. Alex, Betty, and Cindy. And there's that. Okay, and piece X, piece Y. And see, they're leaving out Z. We need to fill that in. So X, what is it, 38%. This percent. 34%. So let's start with Alex. So if we know Alex is 38% and 34%, that's what he thinks. Meaning when Alex looks at that cake, he thinks piece X here holds 38% of the value of the cake, in his opinion, based on the frosting and the size and the whatever. Does that make sense? And then piece Y, Alex thinks is worth 34% of the value of the whole cake. That's how Alex feels. And can we figure out what he thinks of piece Z? How much he thinks that's worth? How could we figure out what percentage of the value he believes Z holds? What could we do there? Anybody have an idea? What could we do for Alex? So if I say the chance of rain tomorrow is 80%, what's the chance it won't rain? 20%. It has to add up to 100, right? So this whole cake, Alex is saying where he thinks the value is. If he thinks piece X holds 38% of the value and piece Y holds 34, Z has to hold the rest, huh? So it has to subtract from 100. So we could just take 38 plus 34 for Alex. What is that? 60, 72. And then take 100 minus 72, which would be 28%. So Alex must think that piece Z holds 28% of the value, because the whole cake's 100%. Now those three add up to 100%. Does that make sense? Let's do Betty now. So for Betty, what does she think? She thinks 37. Whoops, I'm scribbling it all up. 37% and 35%. So how do you figure out the last one for Betty? Same thing. Just add them up. What is that? 72 subtract from 100. 28. 28%. And then finally, we've got Cindy. Cindy, what does she say? 33 and 40. 73, 100 minus 73, what's that, 27? So Cindy thinks 27%, because the other two are 33 and 40. Good to there? Good so far? So we were able to figure out the value of piece Z for each of the three, because they got added to be 100%. Okay, so that's how they feel. So what? Well, these are just percentages. No, it's not money. We're not doing money in this one. We don't know anything about the money, actually. We're just talking about percentage of the value. So if me and one other person, if two people, well, I should right over here. So if two people are going to divide up something, they each want to get what? What percentage do they each want to get to be fair? 50%, which comes from 100 divided by 2. If three people want to divide something fairly, what percentage should they each get? Whatever 100 divided by 3 is, huh? Which turns out to be 33.3%. It's not exactly 33, because 3 times 33 would be 99. It's close. It's 33.3. Now, if you're dividing up something, you're among three people dividing something up, and you end up getting 38%, would you feel like you got a fair deal? Well, yeah, better than fair even, huh? You wouldn't complain. You would feel like you weren't mistreated. You got even a better than fair share. So really, it's that number or higher, right? They will feel they got a fair deal if they get that percentage or higher for three people. If we were doing 4 people, we would take 100 and divide by 4, get 25%. And on you go, right? So that's what we're talking about fair. That's all of our common understanding of fair, right? So that's what we're going with. So basically you want to look at these, and I'm going to circle all the ones that are 33.3, and that matters, or more, because those would be considered a fair share to those people. So here we go. 38, that's more than 33.3. 34, that's good. 28, no. So if you gave Alex piece Z, he would say, I wasn't treated fair. According to my value system, Z, to me, is not a fair share. That piece Z up there, that's small and I don't like that flavor, whatever, who knows. 28%. He thinks only 28% of the value of the cake is in piece Z. So if you handed him piece Z, he would not be a happy camper. He wouldn't feel like he got a fair shake, fair deal. Let's go to Betty. Betty likes X and Y. She ranks both of them above 33.3. But she also does not like Z. And then Cindy Cindy, does Cindy like piece A? Or piece X, I mean? Close, but no. She would feel she was slightly gypped, not technically a fair division. 33.3 or better. So that's picky, but technically the only one she would like is Y, piece Y. That's the only one she would think is a fair share to her, is piece Y. The other two she thinks are below 33.3. They're below a fair share, even if piece X is barely below. No barely for that one. We good? So now what does that mean? Well, that's how we answer all the questions now. That's what they're all asking about. They're saying, all right, so which of the three slices are fair to Alex? Well, X and Y. That's why I answered X and Y. Right, good. Which of the pieces are fair to Betty? X and Y also. Which of the pieces are fair to Cindy? Only Y. That's what they're asking. And then the final question they ask is there a way to give out those three pieces fairly so that everybody comes away feeling that they got a fair piece? Or are we going to need to start over and recut the cake? The way it's been cut, is there a way to give everybody one of those pieces, X, Y, and Z, and everybody will feel in their value system that they got a fair share? No. How do you know? How do you know there's no way to make that fair? You're going to have to recut. Who are you going to give Z to? Who likes piece Z? Nobody. That makes sense? There's no way to do it fair. See how they're going to have to recut. Now, that was a bad cut. That XYZ cut, that was a bad cut. They're going to need to redo the cutting because nobody wants piece Z. It was cut too small or whatever. So nobody wants piece Z. Nobody's going to be happy with that. Nobody's going to, they're not, and our goal is to use math to cut things and divide things in such a way that when all is said and done, every person in their value system says, yep, I got a fair share. So that would not be a fair share. That would be a faulty cut. Is that good? Nobody would like Z. Questions on all that? So just subtract from 100%, get the Z's, circle all the ones that are 33.3 or more. Those are the fair shares. All right. All right, let's start talking about this. So, Jared and Carla, and how they, now who's the cutter on this one? Jared, right? Jared's going to make a cut. Now, Johnny and Abby, the cookie thing, remember it's called divider chooser. That's what we're talking about here. This is divider chooser, meaning one person cuts, the other picks. So what does that make the cutter do? What does that make Johnny do when I say, all right, Johnny cuts, Abby picks? Johnny is suddenly the fairest person in the world, right? Because he gets last pick. Get that idea? That's fundamental to what we're thinking. The cutter will cut it fair in their value system because they're afraid they get last pick. And they're afraid they're going to get less than half the value. Does that make sense? Y'all with me on that? So one more time. The cutter, the divider, in this case Jared, right? Jared's the cutter. Jared will cut it 50-50 in his opinion. In his opinion, is that right? In his value system, right? He doesn't know what Carla thinks. He's just going to cut it fair in his value system. Now, again, this is just silly. They should just talk and say, oh, you like veggie? Oh, well, I don't like veggie. Just have the veggie. That'd be better. Of course, that's always the best answer. But real life, there's a lot. There's some hostile situations. They divide up land. Countries divide up land. People inherit things. There's all kinds of hostile situations where they don't know and they don't care what the other person values. We need math to come in and help in those social situations. So, assuming that they're eating together but can't stand each other. We don't know why they would do that. But they're eating together. They're the sub thing. They don't know each other's value system or care. What will Jared do? Jared's the cutter, so he knows as soon as he makes a cut, Carla's going to pick one half or the other half. So Jared will cut it 50-50 in his opinion, his value system. So what does that mean? What is Jared's value system? He likes meatball 3 times as much as vegetarian. He likes meatball 3 times as much. So this half he thinks is 3x and this is x. Does that make sense? He likes meatball 3. This half he thinks is worth 3x and this is only worth 8. This is 36 inches, 18 is halfway across. X and 3x because he likes meatball 3 times as much as vegetarian. So, what does that mean? What will he do to cut this fairly? Any ideas? Do you guys know how many inches? Would he cut it? Let's talk about, would he cut it right in the middle, for example? Would Jared cut it right in the middle between the veggie and the meatball? Would he do that? Would he make a cut right here? Would that be something Jared would do, according to this? Why or why not? If he made that cut, would those be equal value in Jared's opinion? The veggie half is only worth, right, he thinks the meatball half is worth 3 times as much, doesn't he? So that's not equal, huh? He would think the meatball half is worth way more. And so he'd be scared that Carla would pick the meatball half. Of course, he doesn't know that Carla wouldn't do that. But, again, we're assuming they don't know, because there's many real-life situations like that. So he would not cut it right in the middle, would he? Because that's not equal value to him. That's equal size. Same amount of sub, but not equal value of sub, because he thinks that meatball stuff is worth so much more. So that's not equal value to Jared. So he wouldn't cut in the middle, would he? Would he cut a little bit to the right or a little bit to the left, or what would he do? If he's not going, we cut a little bit to the left. So would he cut like a little bit more over here somewhere? That makes sense? If he cut a little bit more over here, would that make the 2 pieces more equal in value? That'd be worse, wouldn't it? Because now this left piece is a small part of veggie. He thinks, well, that's really worth nothing. I don't like veggie as much, and now you got less veggie. This other one's got all the meatball and some veggie. That's not equal value to Jared. Remember, he'll cut for equal value. He'll cut for equal value. So he won't do that. So he'll cut somewhere over to the right a little bit, won't he? He'll cut a little to the right so that one piece has all the veggie and some meatball, and the other has most of the meatball, so they're equal value to him. Right? He wants to cut them so that they're 50-50 in his opinion, in his value system. Well, how far over? Any ideas? This 3x here, that goes from 18 to 36, could we break that into 3 pieces since it's 3x? How far from 18 to 36? You subtract those, that's 18. From 18 to 36 is 18. So if you divide that by 3, that's 6 each. You tracking with me? So in other words, I could go 6 each. I could go from 18 to add 6 would be 24. Add 6 would be 30. Add 6 would be 36. So this would be x, x, and x. And, oops, let me get it. Come on. Getting all messed up here. And all of this is x from there to there. This makes sense? All of this is x from 0 to 18 because that's vegetarian. And this is x, 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 3x. Every 6 inches of meatball, 1/3 of the 18 meatball part is worth the same as the whole veggie to him, remember? He likes this 3 times as much as that. Now, can you see where Jared would make a cut? Where would the equal value be to Jared? See how he'd cut right here? And there's 2x and 2x. That's equal value to Jared. You see that? He would cut right there at 24 inches because then there'd be 2x value and 2x value. equal value to Jared. All right, that's probably enough, huh? You guys are thinking, we want the test, Mr. Heron.